Let's look at integration using partial fractions. Recognize that in the denominator we have an irreducible quadratic factor. That's what makes this case 3. For a moment, I'm going to ignore the integral and just focus on the fractions. So let's get the partial fractions. In the denominator, the first factor we see is linear. So we'll do a divided by x minus 1. Plus, the second factor in the denominator is the quadratic. So the numerator of our partial fraction will be bx plus c divided by x squared plus 9. Next, we need to multiply both sides by the LCD. That is x minus 1 times x squared plus 9. Again, temporarily ignoring the integral for now. Let's just focus on the fractions. On the left, if we multiply the LCD by the fraction, the denominator will go away, leaving us with just 10. On the right, when we distribute the LCD with the first fraction, x minus 1 will cancel, leaving us with a times x squared plus 9. And then we need to distribute the LCD with the second fraction. Notice x squared plus 9 will cancel. So we have bx plus c times x minus 1. At this point, you may be able to find one letter by choosing clever values of x. Notice that if we let x be 1, in this case, this factor will go to 0, meaning this entire term will go away, and we can find a. Let's let x equal 1. If x equals 1, again, this factor goes to 0, this term goes away, meaning we have 10 equals a times 1 squared plus 9, which is just 10. 10 equals 10a, and then a must be 1. Unfortunately, we can't do that for the other letters. We'll need to distribute this out and equate coefficients. So let's distribute. We get a x squared plus 9a plus b x squared minus bx plus cx minus c. Let's go through and equate those coefficients. Let's focus on all the x squared terms, ax squared and bx squared. A plus b, just focusing on those coefficients, will be equal to the coefficient of x squared on the left side. We don't see a term containing x squared, so that coefficient is 0. If a plus b is 0, and we already know that a is 1, that tells us right away b must be negative 1. Next, we can equate coefficients on the x terms. That is negative bx, or just negative b plus c. That's got to be equal to the coefficient of x on the left side. Again, we don't see that, so it's a 0. Since we already know that b is negative 1, that will be negative negative 1, or 1. Subtract 1 on both sides, and that tells us that c is also negative 1. Now that we have these values, let's rewrite that original integral. We have the integral of 10 divided by x minus 1 times x squared plus 9 equals integral of a, which we found to be 1, divided by x minus 1 plus the integral of bx, which we found to be negative 1, so that's negative x, and c we found to be negative 1, all divided by x squared plus 9 dx. The first integral will be relatively straightforward. This second integral we can break apart into two different integrals using the numerator. So I'll just copy the first integral for now. It's 1 over x minus 1 dx. And let's break apart that second integral. We'll have negative x divided by x squared plus 9 dx plus the integral of negative 1 divided by x squared plus 9 dx. The very first integral is relatively straightforward. That's just a natural log of the absolute value of x minus 1. I'll save the plus c for the very end. Notice that this integral is also going to be a natural log, but it may not be quite as obvious at first. So let's do a u substitution. If we let u be x squared, then du is 2x dx. Notice 2 doesn't occur in that problem, so we'll divide by 2. We have 1/2 du equals x dx. Now rewriting that integral, we have 1/2 integral negative 1 divided by x squared we are replacing with u plus 9 du. Now it looks a little more like that natural log rule. We have negative 1/2 ln absolute value of u plus 9, but we said u is x squared. And again, I'll save plus c for the very end. This third integral looks something like 1 divided by x squared plus a squared. If you recall, that rule is an arctan rule. Remember, the integral of that is 1 divided by a arctan of x divided by a. So this third integral we'll bring down the minus. That's going to be 1 divided by 3. The a value in this case is 3, since 3 squared is 9. Arctan of x divided by 3. Bring down that other natural log from earlier. And finally, we'll add the plus c.